Energy is defined by physicists as the capacity to do work. It is found on our planet in variety of forms, some of which are immediately useful to do work, while others require a process of transformation. The sun is the primary energy source in our lives. Besides, water, fossil fuels such as oil, petroleum products, water, nuclear power plants are sources of energy. The growing energy needs. Energy has always been closely linked to man's economic growth and development. Present strategies for development that have focused on rapid economic growth have used energy utilization as an index of economic development. This index, however, does not take into account the long-term ill effects on the society of excessive energy utilization. Almost 200 years, coal was the primary energy source fueling the Industrial Revolution in 19th century. At the close of 20th century, oil accounted for 39% of the world's commercial energy consumption, followed by coal 24% and the natural gas 24%, while nuclear 7% and hydro or renewable 6% accounted for the rest. Industrialization, urbanization, and unbelievable rise in human settlement have multiplied the energy requirements by several times. Modern lifestyle and man's growing dependence on machine and equipments for his personal and professional work had added the energy demand. Global oil demand continues to grow until 2040, mostly because of the lack of easy alternatives to oil in the road freight, aviation, and petrochemicals, according to WEO 2016, published by International Energy Agency. Renewable energy resources. Renewable energy systems use resources that are constantly replaced and are usually less polluting. Examples include hydropower, solar, wind, and geothermal. We also get renewable energy from burning trees and even garbage as fuel and processing other plants into biofuels. Next is wind energy. The moving air or wind has huge amount of kinetic energy and it can be transferred into electrical energy using wind turbines. The wind moves the blades which spins a shaft which is further connected to a generator which generates electricity. An average wind speed of 14 miles per hour is needed to convert wind energy into electricity. Wind-generated electricity met nearly 4% of the global electricity demand in 2015, with nearly 63 GW of new wind power capacity installed. Solar energy. Solar energy is the light and heat produced from the sun. It is harnessed using an ever-evolving technology. In 2014, global solar generation was 186 terans per hour, slightly less than 1% of the world's total grid electricity. Italy has the largest proportion of solar electricity in the world. In the opinion of International Energy Agency, the development of affordable, accessible, and clean social energy technology will have longer-term benefits. Next is the biomass energy. When a log is burned, we are using biomass energy, as plants and trees depend on sunlight to grow. Biomass energy is a form of stored solar energy. Although wood is the largest source of biomass energy, agricultural waste, sugarcane waste, and other farm bioproducts are also used to produce energy. Hydropower. Energy produced from water is called hydropower. Hydroelectric power stations, both big and small, are set up to produce electricity in many parts of the world. Hydropower is produced in 150 countries, with the Asia-Pacific region generating 32% of the global hydropower in 2010. In 2015, hydropower generated 16.6% of the world's total electricity and 70% of the all renewable energy. Tidal wave power. The Earth's surface is 70% water. By warming the water, the sun creates ocean currents and the wind that produce waves. It is estimated that solar energy absorbed by tropical ocean in a week could equal the entire oil reserves of a world 1 trillion barrels of oil. And lastly is the geothermal energy. It is the energy stored within the earth. Geo from earth and thermal for heat. Geothermal energy start with hot, molten rock called magma deep inside the earth's surface which some point of earth's crust. The heat rising from the magma warms the underground pools of the water known as geothermal reservoir. If there is an opening, hot underground water comes to the surface and forms hot spring, or it may boils to form beer sea. With modern technology, wells are drilled deep down the surface of the earth to tap into geothermal reservoir. This is called direct use of geothermal energy, and it's provide a steady stream of hot water that is pumped to the earth's surface. Next is let's talk about matter. Matter is the stuff that makes up the universe. Everything that takes up space and has mass is matter. All matter is made up of atoms, which are in turn made up of protons, neutrons, and electrons. Atom comes together to form molecules, which are the building blocks of all types of matter. According to Washington State University, both atoms and molecules are held together by a form of potential energy called chemical energy. Unlike kinetic energy, which is the energy of an object in motion, potential energy is the energy stored in an object. So what are the 5 phases of matter? There are 4 natural states of matter, which is solid, liquid, gases, and plasma. The 5th state is the man-made Bose-Einstein condensate. Solid. In a solid particles, they are packed up tightly together so they don't move much. The electrons of each atom are constantly in motion, so the atoms have a small vibration, but they are fixed in their position. Because of this, particles in a solid have very low kinetic energy. Solids have a definite shape as well as mass and volume, and do not conform to the shape of the container in which they are placed. Solids also have a high density, meaning that the particles are tightly packed together. Next is liquid. In a liquid, the particles are more loosely packed than in a solid and are able to flow around each other, giving the solid an indefinite shape. Therefore, the liquid will conform to the shape of its container. Much like solid, liquids, most of which have a lower density than solids, are incredibly difficult to compress. Next is gases. In a gas, the particles have a great deal of space between them and have a high kinetic energy. A gas has no definite shape or volume. It is confined, and particles of the gas will spread out indefinitely. If confined, the gas will expand to fill its container. When a gas is put under pressure by reducing the volume of the container, the space between particles is reduced and the gas is compressed. Next is plasma. Plasma is not common state of matter here on Earth, but it may be the most common state of matter in the universe. According to the Jefferson Laboratory, stars are essentially superheated balls of plasma. Plasma consists of highly charged particles with extremely high kinetic energy. The noble gases, helium, neon, argon, krypton, xenon, and radon, are often used to make glowing sign by using electricity to ionize them to plasma state. A natural process in which elements are continuously cycled is various form between different compartments to the environment: air, water, soil, organism. Examples include carbon, nitrogen, phosphorus cycles, nutrient cycles, and the water cycles. The carbon cycle includes uptake of carbon dioxide by plant, though its ingestion by animals and release to the atmosphere through respiration and decay of the organic materials. Human activities like burning of fossil fuel contributes to the release of carbon dioxide in the atmosphere. The nitrogen cycle involves the uptake of nitrogen from the atmosphere by a process called fixation, which is carried out by microbes or industrial processes. Decomposition of biological waste by microbes can return nitrogen to the atmosphere. Nitrogen is mainly used by humans as fertilizer in farmlands, but in excessive usage can lead to serious problems such as eutrophication. The phosphorus cycles involve the uptake of phosphorus by organisms. Phosphorus in the environment is mainly found in rocks. The natural weathering processes can make it available to biological system. After decomposition of biological waste, it can accumulate in large amount in soil and sediments. Phosphorus is used by humans as fertilizer in farmlands and in detergent. Overuse of phosphorus can lead to eutrophication. The water cycle is the process by which water travels in a sequence from air, condensation, to the earth, precipitation, and returns to the atmosphere, evaporation. It is also referred to hydrologic cycle. Humans use water can transform this water cycle through irrigation or construction or dams, for example.